Thank you for joining us for today's webinar, Mapei UTT Waterproofing and Injection Grout Solutions for Tunneling and Underground Structures. We have some brief housekeeping before we start. Your phones are on mute. If you have any questions, please type them into the Q&A box in the corner of your screen, and we'll answer them at the end of today's session, time permitting, or via email after. And you can always send questions to mapeidigital@mapei.com. Now, without further delay, I'd like to introduce today's speakers, Ramon Quiroz and Monica Rourke. Ramon is the North America Waterproofing Business Manager for Mapei's underground tunneling team. He holds a bachelor's degree in civil engineering and has more than 15 years' experience in the chemical construction industry. He's been involved in managing waterproofing projects during installation, distribution, and sales processes with a focus on design professionals. Working collaboratively with many engineering firms across the globe, he's helped them improve waterproofing design, details, specifications, and has provided solutions to meet evolving challenges. Monica Rourke is the North American Waterproofing and Injection Systems Manager for Mapei Corporation's underground tunneling team. She has over 25 years of experience in concrete waterproofing and leak repair with a focus on providing products and support services for tunneling projects, concrete repair, and waterproofing for both new and repair projects and the stabilization of underground structures. Monica is a fellow of the International Concrete Repair Institute. In 2008, she became ICRI's first woman president, and she was past president for 2 terms of the Connecticut chapter and is a current chapter board member. She's co-authored the ICRI Technical Guideline number 304.1-2006, as well as multiple other papers, articles, and industry presentations. We're excited to welcome them both to our Mapei Online webinar today. I know that they'll present on an exciting topic, and with that, I welcome them to the microphone. Ramon, Monica, the floor is yours.
Thank you. Today, we will talk about waterproofing and injection. Before we start, we would like to take a very quick view about Mapei World. So in Mapei, we have a more than 5,500 products. We have more than 1,000 formula and new formula with R&D. And also we cover more than 66,000 of customers around the world. This is why in Mapei we're going to find we have working through different segments. Today we are with UTT. So UTT, it's a team responsible about underground structure product. Our area of focus is tunneling, underground construction, and mining. And we serve our customer in different product group. So we have a very great solution on injection and soil injection as well, shotcrete, waterproofing, TBM product, coating and protection, and also rehabilitation. When we talk about spray concrete or shotcrete, so we can provide admixture, accelerator, additive to improve the concrete. Also, we have a TBM product like soil conditioning, grouting, sealant. In injection, we have a different type of injection technology as we're going to see today. So we have a microfine cement, biotechnology, acrylic, silicate. Waterproofing, we also have a different type of solution, protection and coating and rehabilitation. Mapei, we provide our customer with innovation, technical support. We have a great experienced team and fantastic logistic and supply. Before we start in waterproofing, I would like to give a very quick introduction about our team here in North America. So in front of you, you will find different type of experts in different fields. supporting with a worldwide support team from Mapei UTT, and also we have our administrative team giving us a very, very great support. Let's start with Mapei waterproofing solution. So first of all, tunneling is different. When we speak about underground structure is different. This is the photo for a station or underground metro station, very close to open. So when we go to the site on the beginning life, it's very, very different. So this is how one project we are working on. So this is the substrate, what we handle. Sometimes we have a very, very complex detail. And this is why tunneling, it needs a different standard. So we speak about different standard comparing with the residential and commercial. Also in tunneling life, we have a different type of exposure and different type of force we need to handle. Most of tunnel project, we are subjecting for a very, very high water pressure. Soil is contaminated with sulfate and chloride. Owner of waterproofing, he need a very, very high class of waterproofing. And also owner, he have a very, very specific requirement about 100-year surface life. So he asking for a waterproofing material that can have a life of 100 years of surface life. And this is why we have, as you can see, we have a different challenge when it's coming on waterproofing. In Mapei, we have a different type of solution when it's coming in waterproofing. So we have the plant seal, that is single component cold fluid applied membrane. We have the Mapei-proof HW bentonite waterproofing membrane. We have a Mapei-Thin, the peel and stick fully bonded membrane. We have a Mapei-proof ALNA pre-applied fully bonded membrane. And also we have a Mapei-elastic TU system and Mapei-Plan TU. As I mentioned, underground or deep underground structure, it is in tunneling different than residential and commercial construction. So most of time on tunneling, we are focused on the last two system, either Mapei-elastic TU system or Mapei-Plan TU. So today we're going to cover a very quick overview about these two systems. Let's starting with Mapei-elastic TU system. So Mapei-elastic, it is a one component ready to use polymeric sprayable membrane and especially designed for tunnel and underground structural waterproofing. As we're going to see here, the membrane, it will be fully bonded from both sides. So first of all, we have the shotcrete surface. We spray the membrane over the shotcrete, and then we have the final lining. So the membrane, it will be bond for both substrate shotcrete and also the final lining concrete. Material coming on double color, so we have a white and green, as we're going to see later, and this is going to help applicator to control the consumption of application. Also, it will have a very high bond strength, so we have a 1 megapascal of bonding. It's a high flexible material and also have a crack bridging capability, high resistance for water pressure, and also have a very good high fire resistance. Our system have a lot of advantage. So first of all, no mixing. It's a ready-to-use product. Material go to the site, connect to the pump, and we start spray. So as we can see here, it is no mixing. So we're avoiding any type of mixing mistake. It's light and user-friendly equipment we're going to use. So we don't need a very heavy equipment inside the tunnel. So it's very easy to handle. And also no rebound. As we're going to see here, material, it is in very easy application. And the most important thing, especially when we're coming for consumption, it is a double color material. So as we can see, we spray first white color, and now we're starting with green color. Surface preparation, when we speak about spray apply membrane, this is a very, very important parameter. So there is a lot of different ways to handle and manage water infiltration inside the tunnel to reach for, as we see now, a very good substrate. We start receiving a sprayable membrane. To reach for this good substrate, we need first of all to handle any type of water filtration. So we can use a drainage board before shotcreting, and once we have shotcrete, we have a good surface so we can spray the membrane. Mapei, we have a different way of reaching for such type of substrate preparation. We divide them for two groups. First group before smoothing layer or before shotcrete, so we can use a drainage strip or drainage bolt, or we can inject, or if shotcrete is done and we start to see water coming, also we have a different method and solution using epoxy treatment or liquid apply membrane or ultra fast setting binder to solve this issue. Here we have a very good photo from one of our projects here in America. It's called Eastlink Tunnel in Seattle of USA. And this picture showing applicator during spraying the second coat or the second color, the green one, after the white, and also showing a very, very good, interesting detail of this dewell or penetration treatment in the tunnel. Second system we're going to cover today, we call it Mapei Plant USWL. It is a synthetic waterproofing membrane, usually used for tunnel and underground deep structure. So PVC membrane, it is one of a very, very famous waterproofing system when it's coming for tunnel. Making PVC famous because he have a lot of a very, very good characteristic like high mechanical resistance. He have also high resistance to permanent pressure, high resistance to root action. Also, he have a high flexibility at low temperature, high resistance to stray current, and explosion resistant as well, high resistance to aging. Besides this very important characteristic, PVC membrane have a high durability. As we can see, the membrane coming with twin color. So we have what is called signal and warning layer. You have a high workability, good weldability, and for sure we're going to see later, we can have a full quality control before pouring the concrete. So we did a different type of test to confirming the long-term effective of PVC membrane, and this is it's available. So we have our system, it's approved for 100 years of surface life as required by owner. And also, as I mentioned, we have a two version of membrane. So we have a membrane that have what is called signal layer. So signal layer, we have the orange color layer. It is on 0.4 mm nominal thickness. And also we have a membrane that have what is called warning layer. It is a thinner signal layer that is meeting the German standard. It is less than 0.2 mm nominal thickness. And the advantage of this signal and warning layer, after applying the membrane inside the tunnel, if any damage happened to the membrane, the signal layer and warning layer, it will be scratched and we're going to see the black color. And this is, it will going to give us a good indication that we have an issue or need to have attention of repair. As I mentioned, the most important part of PVC system, or why PVC system is recommended when coming for tunnel construction, it is overlap, it is welded overlap. So we're using a hand welding machine to weld the overlap or automatic welding machine. Automatic welding machine, it can give us a single weld or double weld. Most of the time, most of the standard asking for double welding overlap. Double welding overlap, that means we have a two seam, one in the right and one in the left, and in between we have an air pressure, or we have a channel, open channel, and we're using this channel for testing purpose. So after we're using the machine and welding the overlap, we can test the joint using an air pressure test. So if we close the beginning of the line, end of the line, we will have this closed channel. We can introduce the air pressure needle. We make a pressure, 2 bar pressure, and then we start to monitor the gauge. If the gauge went down, that means we have an issue with the overlap. If gauge didn't went down, that means we have a very, very good overlap. And again, overlap or welded overlap is stronger than the membrane itself. As I mentioned, the beauty of the system, it is quality control before pouring the concrete. So after we installing the waterproofing membrane or installing the PVC membrane, we can have a full quality control before pouring the concrete. Air pressure test, and also there is another different method of testing. So as we're going to see here, we have what is called visual inspection, manual testing using this special tool or special hawk. We have the compressed air test, air pressure. We can also use vacuum bell, or we can use pinhole detector test that is called spark test. So this brush will going on top of membrane. Once we find the pinhole, we started to have an alert that is sound alert and visual alert that is we have an issue. So as we see now, we have a very, very high quality product and welded and full quality control before pouring the concrete. Another big beauty of the system, what we call it compartment system. So PVC membrane system, we use water stop as a combined of the system. So water stop, we use all construction joint and all expansion joint, it will have a water stop to seal the joint. And we weld this water stop to the membrane to create what we call compartment. So this one compartment, it is around 1,500 square foot of area. And every compartment will have the testing and injection flange. So test and injection flange, we use this for testing the waterproofing system after pouring a concrete, and also in case if we have any damage or any leakage, we can repair the system. So as we see now, this compartment have a 5 valve. This valve is connecting through the blue hose to junction box. So in case of we have any damage, water, it will start to go and showing from this valve. This is why we call it a testing valve. Very easy. Once we start to see water, it's dropping from this blow hose, we start to connect our injection pump and we inject the acrylic gel material through the junction box. And by this way, we started to fill the compartment and to repair the leakage from the source. So this valve, it will give us a very good access to the source of the leakage. In Mapei, we have a very, very big advantage that we have the both system. So we have the sprayable membrane and also we have the PVC sheet membrane. And this is helping us a lot in a lot of projects because sometimes project combine two type of different system. And also as a Mapei, we are able to provide a transition detail between these two systems, between the PVC system and the sprayable membrane system. In front of us now, we have a very good photo from our project in Canada. So it is a tunnel, so we can see the built-up section of the system. So we have first of all the shotcrete. Above shotcrete, we start to lay the geotic style. Then we have the PVC membrane. On top of PVC membrane, we can see the water stop welded. So this water stop in the area where we have a construction joint. And also in the same time, this water stop creating the compartment. So we can see the different compartment. We see also on the right, the blue hose for the injection flange. We are going to use in case of for testing and in case of any leakage. And also we see that is water stop also is backed up with an injection hose solution. In same project, it's another photo when people start to applying membrane to the arch of the tunnel. So we can see here, we start to fix the membrane using a fixing disc to the substrate. We see the overlap, and also we see people start to testing this overlap using a air pressure test. I have also another photo from station application or the station point of view. So we can see also a membrane, it's applied above mud slab on Jotica style. This project, it was a very challenging project because as we see, we have a lot of penetration for anchoring or tension pile. So we have a lot of penetration need to be handled. And also we can see the water stop, it's welded to the membrane for creating the compartment and sealing the joint or the construction joint. Another also station. And here applicator, it's easy installing the PVC membrane on shotcrete surface. And after installing the membrane, they start weld the water stop to the membrane for creating the compartment. PVC membrane also used a lot in cut and cover tunnel. So if we have a tunnel, we're starting as a mining tunnel, and then we have a part, it's cut and cover. So PVC membrane have a very good advantage. It can be pre-applied or post-applied. So even if we have the construction, it's already done, and we have a concrete, so we can post-apply the membrane over the concrete surface. Mapei not only supplying a waterproofing, but also we have, as I mentioned, it is a system. So we supply also all joint solution available. So a system coming with Mapei Plan water stop, it's a PVC water stop, Idle stop multi, this is the injection hose, Mapei Pan TPE, it is a bonded tape, Idle stop, the swelling gasket, and also the Mapei Plant Flex roll. So as we see here, we have a lot or different type of injection and joint solution we're going to use. We finished the waterproofing part, and now I will give the floor to Monica to start with our Mapei injection solution. Floor for you, Monica.
Okay, thank you. Good afternoon. Thank you, Ramon. We can go to the first slide. Injection technology for grouting. The choice of your grout will depend on these categories: the soils, the rocks, the structures, and that will decide for us the selection of the proper grout material needed. Next slide. Pre-injection grouting. The idea of pre-injection grouting is to treat the ground prior to excavation by injecting a grout. Particularly when we are doing the TBMs, we suggest that pre-injection grouting will save them a lot of money on post-injection grouting. But the idea is to drill the boreholes in front of the face of the TBM into the soil to reduce the permeability, which means the water inflow, and improve the mechanical strength of the soil or rock mass. Post-injection would be grouting afterwards. So in this slide, go ahead, Ramon, to the next slide. The pre-injection grouts would include the cement-based grouts, microfine cements, expansive mortars, and then inorganic materials and chemical injections with cement-free binders. Post-injection, our group of grouts include acrylics, silica-based, polyurethanes, epoxies, and admixtures to increase the viability of those products. Next slide. So during our pre-injection, the process of this grouting consists of filling pores or cavities in the soil or rock with a liquid grout. And therefore, we can decrease the permeability and improve the shear strength of the soil. And in that case, we usually start with the cements. That's what most contractors will start with on the low end. And in the picture on the right, you see that if the grain size is too big, it's not going to get to the area that you need. So Mapei UTT, we offer the microfine cements and the cement-free binders. When we look at the grain size and the void diameters, if you look at this chart, we have on the very bottom our Mapajet system, which is a colloidal silica. Then our Microcem 12,000 is an ultrafine cement, and then our Microcem 8,000. So what you have is grain sizes. If you compare it in size to the human hair, you can see that a strand of human hair compared to our microfine cement makes it very, very low viscosity and has great pumpability. Next slide. So those are our two products in our microfine category. We use them for consolidation and waterproofing of the ground through injection. Next slide. We also have a product, the colloidal silicas, which you don't hear about very often. And Mapei UTT has this great product that basically is a low viscosity chemical grout that can be injected to form an impermeable barrier into the ground. What we like about it is it's a good alternative to cementitious grouts, which sometimes cannot be pumped under pressure. And this material also is a low pH grout, and it can penetrate, as you saw from the previous slide, into very, very small areas. It also makes it a little more commercially viable than using an acrylic grout. Next slide. We make the Mapajet system NS right here in America. And with this division of the Mapajet system, we have one that takes about 3 hours to cure, so it can permeate the matrix of the soil. We also have the availability of increasing the reaction time down to even seconds. So the idea is that we have this low viscosity material, and in this slide you can see how under pressure it can permeate through even fine sandy dolomite soil and create a very, very solid matrix. Next slide. We also have admixtures in the UTT lineup. The MapaGrout Compact is an anti-washout. And one of the reasons why I'm showing this material here today, even though we have plasticizers and superplasticizers, is we actually use this quite a bit when we have the influx of groundwater. And groundwater is the most difficult problem during excavation work underground because the water increases the pore water pressure and decreases the shear strength. So by adding an anti-washout, it increases the cohesion. So basically, when you add the anti-washout, it produces the washout of the fines in the cement. Where the admixture is used, the water cement ratio becomes basically the water binder ratio. So we're very lucky to have these materials. We also know in Mapei we have admixtures, but the ones used in our category underground are designed specifically for this type of injection. So the middle picture is the packer, which is similar to packers used for normal grout injection. So we use it, this is a typical packer, and this is a picture of the MapaGrout being injected behind the segments in a tunnel. Next slide. Now for the post-grout injections. This is our family of post-grout injections materials. So we have epoxies, urethanes, rust foam, and foam jet are our families. We have the silicas and the acrylics. Next slide. So here we have a chart, kind of tells you which one you can use. We also have a brochure which covers this more in depth. So when the customer or when the specific situation occurs, we have a chart that we can choose from characteristics and properties and advantages and disadvantages of using one material over another. Next slide. So we have the rust foam family and the foam jet family. The rust foam, we have rust foam 1 km, and this is a one component urethane. It's a hydrophobic. It's quite fast reaction. It has a tight cell structure. We use it quite a bit because it's easier for mobility in terms of using an airless spray pump. We also have within Mapei the other rust foams, which are the 45, which is a hydrophobic, the 35, which is a hydrophilic, and our SS75. They are all NSF approved. So many times underground, where we have the requirements for NSF material, we have the viability of using those. We keep this one component urethane. We use it quite a bit, and it's also made right here in America. Next slide. Here's a picture of us using the Rust Foam 1KM. These are caissons at the Billy Bishop Airport, and this is in right outside of Toronto. And here they are drilling into the caissons. You can see where the injection ports are. This particular job was injected previously and had residual leakage, so we were able to incorporate the Rust Foam 1KM and do a second injection without mechanically removing the first injection and stopping all the water. Next slide. The foam jet family. The foam jet family consists of two-component polyurethane resins. When I say a two-component polyurethane, I'm not talking about what comes in the package. I'm really talking about how it's going to be pumped. It's going to be pumped with a two-component pump, and you're going to have component A and you're going to have component B. You can also accelerate the material to make it go faster. What we like about using the two-component materials, especially underground, is because there's no travel time by putting a catalyst in a one component. It still has to travel through the injection hose. Here we can inject right at the point of where the packer is, and we can turn off very, very high pressure flows. This is a picture that I took last month in Hartford. You can see on the left that they're pumping out all kinds of water. We have component A in a 55-gallon drum and a component B right in front. So we're pumping right out of the containers into the packers. And on the right-hand side where you see the rags hanging, that's an injection packer that's going to be injected. And we are inside the TBM as we're doing this. Here on the left-hand side, you can see the flow of water that we have to stop when we're inside these TBMs. It's massive water. These kind of structures, wherever you drill, geysers of water shoot up. And that is why you want to use a two-component material, because it gives you a greater cure time, much faster, and it's a stronger material in just about a minute. Okay, we also use on the right-hand side, go ahead. On the right-hand side, we have observation ports. So where you show the injection at one point, you always use an observation port. It's open, it lets you know where that material is traveling and that you have communication between your injection points because you know that you've filled the area behind the segment. Next slide. We have in our family Foam Jet F. This is another two-component material. This is a great product because it can cure in the absence of water and hardens without increasing the volume. So therefore, you can have it as a foam, a very strong foam, but it also will expand whether there's water or not. And we know with our urethanes that basically water is the catalyst. So with this special chemistry, the material can cure in the absence of water. It's used quite a bit in the consolidation of rocks and waterproofing structures and a lot of cracked walls where you need a little bit of elasticity. Here's some pictures of the cured material. What Mapei UTT has done when we have a family of materials and then we get feedback from our customers or from the job site, we need a material that expands a lot. We need a material that goes fast but doesn't expand. We need a material with a tighter cell. So therefore, we have the same name, but we have different characteristics and properties that are going to be inherent to that particular grout in that particular application. Next slide. We also have Foam Jet 260 LV. The LV stands for low viscosity. This is an elastic resin. It has a very dense cell structure. So if you have sometimes a urethane can have a very high viscosity and you want to get it into a very fine crack. So this material you would use for that. You can use it on hairline cracks. Again, it's a two-component material, and it also has a very strong cellular foam once it's cured. Next slide. So you could use it, for instance, this is a manhole. So you have the options of selecting a material. Here you could use the two component because you have fine cracks. You also know that you're going to have cracks that are subject to water and cracks that aren't maybe subject to a lot of water. So you have a selection of materials that you can use, and a lot of times that may be based on the access and mobilization. If you can't get a pump down there, but you can run a two-component pump and run the lines down there. So we give the customer the viability of some choice, still staying within the characteristics and properties of the grout material that's selected. Next slide. We also have the silicates. The silicates are an organic mineral, and I would tell you that the silicates are probably the most used grouting material, and very many different derivatives of the silicates. There's about 600 different kinds of silicates. In this case, we have what we call a urea silicate, urea coming from the polyurea family, which would be your polyurethanes, and then the silicates. So here we have materials that can foam, can glue, and can travel very easily. Again, two-component material, fast reaction. Our silica jet, again, like our other families, we have 3 different family members of our silicate family. This one is high expansion, 40 times. We use it a lot for backfilling in the tunnels with when we're using TBMs. The expansion factor would be relative to the space it's filling. Here we have the Silica Jet ST, okay, which has a very, very high mechanical strength and high adhesive properties. So again, it's targeted for cracks and fractures. Again, you can use it in rocks and soil. So it comes in the drums, and here we have soil where it can be used very successfully in gluing all this rock or soil together. And if there's water, it will cure up and stop the water. Next slide. We also have our acrylates, our acrylic family. As Ramon mentioned, we have the acrylates for compartmentalized grouting and injection hoses. We also have our acrylates, which are very low viscosity, environmentally friendly, you know, very low viscosity. Here's a picture of, I'm actually doing these caissons and injecting very, very, very secant pile fine lines that you can't even see. So I can do joints, I can do grout curtains, and I can do fine cracks with this material. What we like about this material is everything washes up with soap and water. That means the equipment washes up with soap and water, and the environment washes up with soap and water, and yet the material is a true hydrophilic, and that means it can swell and re-swell because it's a physical reaction as opposed to a chemical reaction. So a urethane is a chemical reaction, goes from a liquid to a foam or a solid resin, where an acrylate is if you had a glass of water and you put salt in it and mixed it up, you couldn't see the salt crystals. If you took all the water out of that glass, you could see the salt crystals again. So what we say is it's a physical reaction, and it can swell and re-swell. We have jobs that have been done underground that are lasted 25 years. Here is another acrylate injection that we did in Toronto. It was the Eglinton station. And behind these precast segments, a lot of times these precast segments have little hairline cracks. They also link at the joints. This is a great material to use for post-injection after the precast segments have been set in place and the contractor is showing that he has to stop the water that's coming in the post-injection part of his job. Next slide. So we have complete solutions, and I'm going to turn it back over to Ramon. Ramon, would you like to go over our complete family?
Thank you, Monica. As we see today, we have a different type of product range, can meet every project, and every project, it's a unique project and it's a special project. So we have a proven product for tunneling, mining, and underground structure. Starting again from admixture, accelerator, injection material, waterproofing material, how Mapei can support. So if you have a new project in the work, we are very, very happy to give a quotation. During construction, usually we support project with a lot of site visits. Also in our TPM, it is an admixture team, it's ready for lab testing. So if you need any type of lab testing for injection material, for concrete admixture, for TPM product or soil conditioning, we are very, very happy to give you the full support. Also, we are working a lot with designer and with engineering on specification. So Mapei can support with giving a specification, working on detail. Also, we are working in a very, very specific detail. When we are coming for difficult work environment, and as I mentioned at the beginning, tunneling usually it is very deep, too many exposure. We are working in too hot condition or too cold condition most of time, and we are in a wet condition. So we are very, very happy, or we have the right solution to provide to you. We didn't supply only product, so we supply product, we supply a full system, we supply also innovation, and most important thing, we supply a technical support. So we provide a technical support, as we can see here on the picture. Our PhD Christina trying and soil conditioning material and giving a full technical support on site. Thank you, and if you have any question, we are very, very happy to answer your question.
All right. Thank you very much, Ramon, and thank you, Monica. And let's see. Looks like we don't have any questions at this time. If there's anybody in the audience that wants to ask any questions, there's the question and answer box in the corner. I have a raised hand. Let's see. Oh, I'm not seeing anything. I'm sorry. It looks like we may be having a little bit of technical difficulties with that in the questions. All right, so I'm not seeing any questions in the question and answer box. It should be in the panel. If anybody's wondering where it is, it should be in the panel. It's either in the right or the left-hand corner, and you can type your question in and we'll answer it for you if you have anything. If it isn't working for some reason for you, you can always send your questions to mapeidigital@mapei.com, and we have our emails turned off at the moment, but we will monitor them after and forward anything to Ramon, to Monica, to the appropriate person on the UTT team, and make sure that if there are any questions, they'll be answered. And with that, that will conclude today's Mapei Online webinar. And we thank you, Ramon and Monica. That was an excellent presentation. And we thank everybody in the audience very much for taking time out of your busy day today to join us. We know that things are very busy, so thank you. And we will see you all next time. Have a great rest of your day, everybody. Bye.
Thank you.
Thank you. Bye-bye.